presenting on realization of silicon nanowire vertical surround gate field effect transistors by Schmidt et al. Published in 2005 by Small. So semiconductor nanowires have important applications in miniaturization in microelectronics. The concept of silicon VS-FET, which is a vertical surround gate field effect transistors, which I'll be referring to as VS-FET for most parts of this presentation, would require an n-dope nanowire in the region of the gate and a p-dope elsewhere, making a PNP structure. But this is difficult to achieve with the VLS mechanism, that is the vapor liquid solid mechanism of making nanomaterials. So what was done in the case of this VS-FET was that uh, uh, silicon dioxide was used as a substrate, which is that was p-doped, and then silicon nanowires were grown on the substrate, which is a source of the N, or which are n-doped. So by chemical vapor deposition, silicon dioxide was deposited, followed by aluminum, and then by polyamide. The aluminum acts as the source. So basically, we have a p-doped substrate with which is about 10 nanometers thick with silicon nanowires grown on it, and then silicon dioxide again deposited on it with aluminum also deposited on it, and then a polyamide with the aluminum acting as the gate, as the source, sorry. So with the electrical analysis of this particular device, this transistor device, the diagram in the presentation shows the output, characteristics of an array of the VS-FET for different gate voltages. So from what you get from there is from the diagram is that for positive drain source voltages, the drain source current depends on the gate voltage, and then also for the negative drain source voltage, the dependence of the gate voltage dependence of the current drain source is similar. In the figure for small values of gate voltage, the increase of the drain source current at low drain source voltage values are nonlinear, indicating a series of resistance which may be due to incomplete formation of the inversion channel close to the interface of the N-type nanowires and then the P-type substrate. So yeah, so that is where the next step is actually minimizing charges trapped within the silicon nanowires, which is the N-type, and then the silicon dioxide, which is the p-doped substrate interface. The array of the VS-FET exhibited a gate voltage dependent current increase of more than 2 orders of magnitude.